This is an introduction to the Solar Position tool of Dhour, a powerful component for plotting both orthographic and stereographic sun paths over the course of a year. For those less familiar, orthographic projections plot the sun's path in Cartesian or x and y coordinates. The sun's azimuth, or angular direction from north, is plotted along the x-axis, and the solar altitude, or vertical angle from the horizon, is plotted along the y. A stereographic projection represents the sun's changing position through the sky, mapped as if we were looking straight up at the sky, with the origin as the zenith. The plotting of the sun's path from summer to winter will overlap its path from winter to summer, which is why the graphs have been separated into two halves of the year. These halves are not identical, so it's important to look at both. So let's begin to build our own solar position graph. I'm beginning with a set of d-hours which I've colorized according to hourly temperature and humidity using the double gradient colorization. This will give color to the solar position graph. We find the solar position component under the d-hour Spatialize tab, and we can plug in our d-hours as the first input. This ought to generate an initial spatialization, which we can see defaults to stereographic. If we wanted to change the type, we could use any string to input the word ortho to represent orthographic into type. You can also right-click on type and set the string here. And now we see an orthographic plot. We can change its location if we would like to create adjacent graphs by right-clicking, saying Set One Plane, placing its new base plane accordingly. We also have the option to change its dimensions with this third dimension input, and that requires using the domain squared component and then a couple panels to set the ranges for the U and V values. So I'm going to say 0 to 8, and 0 to 4. You can set the proportions to be whatever you'd like. As soon as we have this plugged in, we'll be able to see how it's rescaled. The fact that we're able to see a plot at this point is a good sign. It means that the solar position component has already recognized our data hours keys for the solar altitude and the solar azimuth. If yours hasn't made that connection, you'll need to copy that specific key name and plug it into a panel, which you'll connect into this altitude and azimuth input. The final input, cold night hours, represents the hours when the sun is not visible, and so when its location is not needed. These hours are cold by default. However, this can be changed by right-clicking and setting the boolean to false. So now to consider our outputs. Our graph is currently overridden by the red rhino preview, so I'm going to call out the points which trace the sun's actual position, as well as the colorized mesh. Now to consider our outputs. Our graph is currently overridden by the red rhino preview, so I'm going to call out the points, which trace the sun's position, as well as the colorized mesh. We now notice the effect of having both halves of the calendar year plotted at once, because the sun appears to be making figure-8 patterns. But by using the mask hours component, we can filter the hours to only read from December to June. To do that, we'll use our filter mask hours, create a little space, and then we can plug a new hour mask using a panel which describes our time period. We'll say winter solstice to summer solstice. And then allowing that all to register. We now see a distilled version of our plot, although it's still a little rough around the edges. And that's because the lines and colorized mesh are generated by extruding from the solar position points, so these edge conditions should be trimmed. The trimming boundary, in this orthographic case a rectangle, is the final output. And I'll use a handy cluster definition, which I can show you in a little more detail, which will take that boundary as well as the colorized lines from the plot to trim those colorized lines and get rid of the extraneous segments and colors to give us a cleaner graph. So by plugging our outputs from the solar position in, and turning off what we were originally viewing, we'll then use our Bacon color script written by Giulio Piacentino and plug these colors and lines in for the geometry to view our new trimmed plot. This plot can then be copied and adjusted according to type, scale, or masked hours of the year to create our original foursome. Happy plotting!